All right, let's get started. Okay, we have PS6s out and due at the end of the week. And then there's fall break. Remember, the midterm is 2 weeks from today. For those in the regular section, it's at the usual time, 3 o'clock, either in here or next door in 103, depending on your last name. And for the hybrid section, it's in here at 5 o'clock. I've heard from a few people with a conflict. Presumably people from the hybrid section have a conflict with this. I need to hear from you soon if there's a problem taking the midterm in the available slots. Any questions or problems about anything before we proceed? Yeah. It's 2 weeks from today, which is October 16th. 16th. Wednesday, October 16th. I put 2 sample midterms, one from 2017, one from 2018, up Monday. So it's sitting on the schedule, the class schedule for the week after fall break. So you can look at those. We'll go over solutions after fall break. Anything else? Yeah.
In a few of the lecture problems that we went to in earlier lectures, there were situations where a string or an integer was created and then sort of iterated on or replaced as they were added to a hash map or a set, a collection of some sort.
Mm-hmm.
How is that done when it's not a string or an integer or one of those things, and it's a collection itself, like putting the array list inside of it?
Okay. So this question is, let's suppose you have a hash map, and the key is a string, and the value is an array list of something. Right, that's what you're asking about?
Right.
Specifically, what's the question? How do you...
So, in some of the we created like an infinite number of strings that were added to a hash map. How do we do that if we're creating an infinite number of array lists?
Well, so a common... so first of all, let me just mention that this current assignment you're working on involves hash maps and array lists. There are a number of examples from last week in class about those sorts of things that would be good to review before you work on PS6. But if you have some sort of loop that's populating, let's say you have a hash map like this, just call it map, and let's say you've created it, and then the question is, how do you populate with array lists? Well, here's one idea. You tell me what's wrong with it. What if I did this? What if I created an array list of, I don't know, let's say integers. And we'll call it list equals new, and then I'm tired of writing. Anyway, we create a new empty array list. And then we have some sort of loop. And each time through the loop, we do something like we add stuff to list. Then we create a key some way, create a key, and then we do list.put key list. Okay, so that's sort of the general schematic. So what we're doing is we've got some loop. Maybe we're reading from a scan, or I don't know where we're getting the information. But as we read, we add stuff to that list that we created up there. And then when we're through putting stuff in the list, we get a key from somewhere. And we do list.put key list. So now in the hash map, key maps to list. Okay? So how would that work? Or would it work? Yeah?
You said that this was an idea that wouldn't work, correct?
Right, it won't work.
Because the key is what's being changed, not the list.
Well, don't focus on the keys. We got some source of keys. the keys aren't the problem. It's the list.
Only one list is created.
Right. There's only one list. Look in this whole deal. We only ever create one list. And so the picture you get is, if this is our map over here, let this be our map, and it's going to map keys. So we've got K1, K2, K3. Those are the keys. K1 is going to end up mapping to some array list. What's K2 going to map to? The same array list. You're always using the exact same array list. And so that means that every number you ever add in any iteration of this loop I'm proposing will just be added to the same list. So you end up with one gigantic list that all the keys map to. That obviously isn't what you have in mind. So how do you fix this? You can fix it by drawing a single arrow here, moving one line of code. Yeah?
Using the declaration of array list and list inside the while loop.
Right. What we do is, each time through the while loop, we create a new array list, add to it, throw it into the hash map, and that way you end up with a picture that looks more like this, sort of, where everything maps to a different array list. Because every time through the loop, you're creating a different array list for the key to map to. So that takes some getting used to. That it's when you take an array list and stick it into a map, I think a lot of you are thinking, oh, it makes a copy somehow. And I don't think you're thinking that, you're not saying that in so many words. But when I see the kinds of questions I'm seeing, it's this misconception that if once we take a list and stick it into the map, it's somehow independent of the list that we have in our hand. But it's not. I put an analogy on Piazza today. If you have a car and you loan it to a friend and they wreck it, is your car wrecked or just a copy of your car? Right, it's your car. Same way with these array lists. If we create it outside the loop, we only ever create one list, and so every reference is to the same list. That's why we need to create a new list inside the loop so that every key gets its own list to map to. Yeah?
Did you mean to put map.put or that list.put?
Oh yeah, that's what happens when I get too hurried. Thank you. Yeah.
Just so to make sure I understand, so if we would have left it the way it was the first time, the problem would be like you'd have an array like California 12, California 10, California 6, as opposed to California 12, 10, and 6.
No, the problem would be maybe you want to create a map for a list for California that contains 8, 2, 7, and 4, and you want a list for Utah that contains 1 and 9. And a list for Nevada that has like an 8, a 7, and a 2. But if we did it the original way, we'd end up with a single array that contained 8, 2, 7, 4, 1, 9, 8, 7, 2, that all the keys map to. Because we only, if you just look at the code, if we keep that, it only says new one place in the program. This is the only place where a new array list is being created. If we only execute that new once, there is only an array list. There's only one array list. It has to be the same list everywhere. By creating a new list each time through the loop, then we create separate lists for each key. All right, let me build on this. Maybe I'll save that in case I want to come back to it. Suppose we do this. Suppose we create a new scanner, and then we say y gets x, and then we say y dot, we get the next token out of y. So we've modified the scanner. Does that impact x at all? Does the fact that we've called y dot next, does that affect what will happen when we call x dot next? In fact, let me make this more concrete here. Let's give it create a scanner to read this thing, A, B, C. So when we do y dot next, what will that return? Yeah, return the string A. What will happen when we do x dot next? Right. Okay, we get A, not B. Because, again, x refers to some scanner object out here. When we assign x into y, we're not copying the scanner. Y just refers to the same scanner as x. It's not copied. It's the same thing. And so calling y.next is the same thing as calling x.next. And so, yeah, we call y.next. That removes... Man, no wonder you're all looking confused here. Okay, sorry about that. So calling y.next gets you A out. Calling x.next gets you B out because the A was already removed. Sorry about the mistake. Now, it looks like you want to ask a question. Is that?
Oh, yeah, so I'm saying, is that similar to the lab we had, not this week, but the last week where we created it, and then when we made that separate one, like for argument, let's say C1, C2,
Right.
whenever we made an edit to C2, and then if we went ahead and said like, display C1, it would actually have the modification that we just made C2 apply to it.
Yeah.
Okay.
Yeah. If I remember, when we're using the debugger today, I'll show you. I don't know if I pointed this out in the lab or not. But when you use the debugger and look at the values of variables, let's say a variable contains a reference to a scanner. It'll contain an ID number. It'll say ID 52. And that's meant to uniquely identify that scanner. And so if two variables both contain scanner 52, it's referring to the same object. All right, let's take, let me change it again slightly here. I'll get rid of this. And let's create a method here, void f, scanner y, and let's say in here we do y.next, and up here we do x.next. Is this any different from our last example? Sorry, we got to call f right here. So we call f of x. So we do three things. We create the scanner, we call f, we pass x as a parameter, and then we do x.next. What will this y.next give us? Yeah, it'll give us A. Then we return from the method and do x.next. What will that give us? A or B? Yeah, it's the same deal. Because, outside here, x refers to some scanner object. When we pass x as a parameter, what happens is this y that the method knows refers to the exact same object. It's not copied again. And so y.next gets us A out, and then when we return, the scanner x refers to has been modified, so x.next gives us the B out. Yeah?
Where did you declare scanner?
Where did I declare scanner? Well, okay, I declared y right here. I guess I need to declare x here. Scanner is imported from somewhere. So this is, I know from experience this idea confounds a lot of students because they sort of have this model in their head even though they don't realize it, that somehow copying is involved. But with objects, it's all done by passing references around, not actually copying any objects ever. And as I've mentioned before, it doesn't matter when you're talking about strings. Okay? Strings are immutable. You can't change them, and so you can't set up an example like this with strings. So whether strings are copied or strings are shared via reference is immaterial. You can't tell the difference. Program won't behave any differently no matter what it does. But for mutable objects like scanners and arrays and array lists and hash maps, it definitely matters. Okay. Any last questions? Yeah.
So in order, like, if your expected thing is so that they both return A, you have to create some sort of new scanner object in void f, right? Or
Yeah, so, I mean, if you did this, suppose we did this. First thing we do is we say y gets new scanner, and we pass it A, B, C. Now how do things change?
They're both, wouldn't there be two construction scanners though?
Say what?
Wouldn't there be two scanners?
There are two scanners. So my picture now is, as soon as F is called, Y refers to that object. But what happens when we execute this, this Y gets new scanner ABC? Then we go and create a new scanner object to which Y refers. So now X and Y are referring to separate scanners. And now we do Y dot next, we get A. We do X dot next up here, we'll also get A because it's now on two separate scanners. Okay, anything else? Okay, keep this stuff in mind as we're going today because we're going to be looking at, we'll see, these issues will come up. These pictures will come up too. Okay, here's what I want to do. Let me make this bigger. I want to implement a class. Okay? Remember we talked last time that when you can create new types of data by implementing a class as opposed to just using a class to contain static methods. So I'm going to create a class called MyList. And up here is the Java doc. It says it's a simple dynamic list of integers. So what your model should be is we're creating a class very similar to array lists. So let's see what you can do with a MyList. You can create a new empty one that way. You can, and these are lists of integers. So all you can add to them are ints. So we can add like 15, 7, 20, and so on. So you can add arbitrarily, and the lists deal with that. There's no limit. You can look up the elements stored at a given index. So that would return whatever stored at index 0 of list 1, which would be what in this example? 15, right? Because that's the first thing we added to list 1. You can change what's stored. So this would change, whatever stored at index 0 gets changed to 8. And you can ask a list its size. So those are the methods we want to be able to provide. So given that that's what we want, what will the rest of the class contain? What does the rest of the class have to contain if those operations are supported? What are we going to see when I scroll? Okay?
Methods called add, get, set, and size.
Okay, so there'll be a method called add, there'll be a method called get, set, and size. So there'll be these 4 methods. Okay, someone else tell me, what else will we see? Yeah?
You'll see the MyList method or constructor.
You'll see the MyList, there'll be a MyList constructor that takes no parameters and initializes an empty list. What else do we need? Yeah?
Some sort of like array or variable that will hold the numbers.
Okay, we'll have to have some instance variables to keep track of everything that's being added to lists. All right, so let's scroll and look. There's our instance variable. I'll come back to it. This is our constructor that creates an empty list. Not implemented yet. This is our method get, which takes an index and returns what's stored at the index, or it throws an array index out of bounds exception otherwise. This is our set method that takes an index and a new value. This is our add method that appends to the end, and there's our size method. So right now they're just stubs. So here's the thing. We're implementing the class. That means we have to answer a key question. As objects are created, those objects will contain one or more instance variables, and the job of those instance variables is the same in each object. Each object has its own copy. It's got to somehow keep track of all the information that we need to keep track of. So in the case of a list object, what does a list object need to know about itself in order to be able to deal with methods that get called on it? What needs to be stored inside each object? Okay, an integer. Okay, certainly at least one integer. Would that be enough to have a single integer variable? Now, suppose you cut an array list open and looked inside it. Okay? An array list contains some instance variables. What would you expect to find inside of an array list? To keep track of all the numbers that can be an arbitrary number of things added to an array list. There could be 1,000,000 things inside in the list. What kind of instance variable would you need to keep track of 1,000,000 things? Probably not a single integer. Any ideas?
Index.
Well, index into what? Yeah.
An array.
Okay, an array. So array lists contain. So if an array list contains inside it 100 elements, I mean, if you've added 100 things to an array list, what you'll see inside in the debugger is there'll be an instance variable, which is an array that actually contains all the elements. So that's what I've done here. I have declared an instance variable called data. It's an array of ints. It says holds the elements of the list. So when the add method is called, what the add method will actually do is store them in the data array, that private data array. And remember, there's one of these arrays created every time you create an object. Each object contains inside itself one of these arrays. And it says is exactly the same length as a list. So if you've done 10 adds to the list, there'll be 10 things in the array. The array will be of length 10. And it says that element I of the list is stored in element I of data. So that just says that the first thing you insert into the list is stored at the beginning of the array. Next thing is the second thing in the array, and so on. So to implement a class, you first got to come up with a plan. And the plan is also called a representation strategy. You basically got to answer the question, what instance variables does each object need to have if that object is to be able to function? And what I decided was, all I need is for each object, each instance of the class to contain a single array, and that'll be sufficient. And implementing the class means turning operations on lists that the user wants done into operations on this hidden array. So we need to make this thing behave like it's specified. The user doesn't know about the data. Whoever's using this list doesn't know or care about the instance variable. You don't care about the instance variables in a scanner object. You just use the scanner. You don't care about the instance variables in a string. You don't care about the instance variables in a hash map. You just use the methods. But if you were to implement a scanner or implement a string or implement a hash map, then suddenly it'd be your job to figure out what instance variables do I need? What's my plan for keeping track of the data? Okay, so let's see how this works. This says creates an empty list. So given this comment right up here, if we want to create an empty list, what sort of array should be contained inside the object? How long should the array be, and what should be stored in it? Should be able to answer that question from that comment. That comment right here is crucially important. That gives you your plan for representing data. So, what do I need? Yeah?
We need the amount of things stored in the array to be infinite or to be adjustable.
Mm-hmm.
Or use the
Yeah, but there's this.
count of I.
But this is part of my plan right here. At any time, the number of elements that have been added to the list should be the same as the length of the array. So if we're creating an empty list right here, what kind of array should there be inside? An empty array, right. So we'll say data equals new. So that's what our constructor does. It initializes the instance variable so it contains an empty array. Because that's how we're going to represent. An array of a list with nothing in it is represented internally by an array with nothing in it. A list with two things in it is going to be represented by an array with two things in it. Right? So let's come down here. Suppose sometime in the future someone comes along and asks what is the size of this list? There's a method called owner the object, and it asks, what is the size of the object of this list? How do we answer that question? How could we tell? Yeah? Right, we've set things up. Remember, we're going to make sure, as we write our code, that the size of the list is always the size of the array that it contains. So all we have to do to answer this question is return data.length. Great. Let's do add. So you are an array object, and a MyList object, and someone says, okay, add this number to yourself. Add val to yourself. Okay, we got to keep track of that number. Where are we going to put it? Yeah, someone said the end of the array, but what's the problem with that? Yeah. Our arrays are fixed length, and right now the first add will be to an empty array. So what do? There's not room for the array in our for the number. Yeah.
Create a new array.
Right. Create a new array that's bigger. Create an array that's one bigger, and then put the value into the array. And so we need to copy the array. So it turns out there's a useful method I'm going to use. There's an arrays class dot copy. What is it? Is it copy of? Yep. Copy of, and we're going to give it data, and we want to have the array to be this long. So what this does is it takes an array and copies it into a new array that's one bigger. It copies everything over, and then the last element will be undefined. Okay? So that's our new data array. So if we started out with an array of length 10, now we have an array of length 11. So what do we do with the value? Where do we store it? Somewhere in the array. What index should we store it? Yeah, we need to store it at the end, because that's where the open spot is. So that's just data.length minus 1. Now, at this point, before we finish, we can try this out. So I'm going to put a breakpoint right here, and we're going to debug. And let's watch what happens. No. Wait for it to hit the breakpoint. For some reason, it doesn't want to do that the first time I run it. So try again. Okay. So there we are. First thing we do is we call the constructor. So let's I'll step over that one. And notice list 1 showed up over here. And if I open up list 1, I will see, there's a data array inside the object. Okay, that's the instance variable for the object. And it's telling us that is ID 23, so that's object number 23. And I clicked on it, and it shows that list 1 contains a data array which is empty. Okay? So now I call this constructor, and same thing happens. List 2 contains something called data, because that's the instance variable, and it's also empty. Now we're about to call add 15, list1.add 15. What's going to change about my picture on the right when I execute that method? Okay, let's look. Right now, it's array number 23 is inside list 1, and array number 26 is inside list 2. You have to take my word for it if you're sitting in the back. But there's a number that says what it is. When we add 15, is anything going to change about list 2 when we add 15 to list 1? No, they're separate objects. What will change about list 1's data instance variable? Okay, it'll have a 15 stored in it. So instead of seeing the empty array down there, we'll see 15 in it. What else is going to change? Yeah. the ideal change because it will be a different array. So let me step over it. And now, you see this is highlighted. Data now contains array number 27. So the old array has been discarded. The new one has been copied over and populated with that 15. If I click here, you'll see that now the object contains an array that contains 15. If I step over the list2.add7, okay, right now it's list2 contains data array 26. I step over it. Now it's 28, and its value is at list 7. If I add 20 and 9 and 25, we keep getting different arrays. Now list 1 contains the array 15, 20, 25, and list 2 contains the array 7, 9. So you see that the array that we've arranged for each object to contain is growing. And then we go on to ask get of 0 and set and so on. It works sort of the same way. Now, I want to stop this and start it over and show you something else. So there we are at the constructor. Let's step into the constructor and see what happens. So we're inside the constructor. What's about to happen? If we look inside, oh, look right there. That variable is called this. Okay, what is this? The object in which the method was invoked, or in this case, the object in which the constructor was invoked. So when we said new, up in the other method, up in the main, when we said, okay, create a new MyList, this new here created an object that needs to be initialized, and here it is. It's this, and this contains a data instance variable. It's currently null. So let's watch what the constructor does. It works on this object over here, the object in which the constructor was invoked, and initializes it with an empty array. And then we return. If we want to, let me step over that, step into this one. Now we're at the constructor again, but now this is number 28. Why is this referring to a different object now than it did the first time? Yeah?
Because you created a new int array.
Right. We are, right. This is relative. This always refers to the object, in this case, the object in which the constructor was invoked. The first time it was invoked on a different object than the second time. So of course this will be different. If we crack open this, it's null. But we're about to create an array to store there, number 29. And now when we step out, we have two lists. Two different lists, number 22 and number 28. Number 22 contains array number 25, and the other one contains array number 29, so different arrays. We call 15, let's call add now. I'll step into add. And wait, I stepped over add. So I'm going to step into add here. And you'll see, there is this. What is this referring to in this case? I'll remind you where we were. We were up here in main, and we invoked list2.add7. So if we look up, okay, so what is this referring to in the context of this method here?
Creating the new array.
Well, this isn't, well, we're not to the point of creating a new array yet. This doesn't refer to an array anyway. What does this refer to? The object in which the method was invoked, which was list 2 in this case. And so that is object number 28. That was list 2. And now you'll see what it's going to do is it's going to make that copy. So if you watch, right now, if I open up this, it contains that data array. I step over that assignment, and now I have that array because I added 0 to it. Well, no, I have that new array, and then I'm about to store the actual value in it. That's what it looks like. So this method here operates not, it takes no parameters, but it operates also on this. Add operates on this. Set operates on this. Get operates on this. constructor operates on this. It's always the object on which the method was invoked. It's called the implicit parameter because it's implicit. You know, it's the implicit parameter. The object in which the method was invoked is the thing before the dot. So up here, when you say list1.add 15, 15 is a parameter. You're used to that. List1 is also a parameter. It's the implicit parameter. It's what's called this inside the add method. So list1 is passed as this. You just got to get used to that. I mean, if I said something like this here, why is that an error? Why can't I call add 15? Right. What object am I calling it on? You have to say what object to call it on. In other words, you have to provide the implicit parameter for that to work. And you've been doing it all semester. You've been providing implicit parameters. We just haven't been talking about them as parameters. But it's just the object in which the method was invoked. All right, let's finish this class off. I need a get method that returns the value stored at a given index. Okay? So we've got some object. How are we going to find the value stored at? So I've got a MyList object. We want the thing stored at index 2. What's stored at index 2? How do we figure that out? Where in the data array would the third thing to be inserted into the list be stored? Would it be the first element in the data array? The last element? Where would you find element index? Where would the first thing stored into the list be stored in the data array? Index 0. Okay? Second thing's at index 1 and so on. So what should we return here? Data sub what? Data sub index, yeah. Now, what if it's a bad index? If it's a bad index, this thing here is going to throw an array index out of bounds exception. That's just fine with us. We'll let it propagate. Yeah?
Do we need to then say throws array index out of bounds?
No, you don't have to use throws unless what's propagating is a checked exception, such as file not found or something. Something to do with external problems beyond your control. Okay? What about here? We want to change what's stored at a given index of the list. Well, that sounds easy enough. We'll just say data sub index gets val. We just change what's stored inside the internal array. There's add and there's size. So I think that's correct, but I have a set of tests here. I'll run, make sure we pass them all. Okay, that's good. And let's go back to the main method. I want you to notice something. You do not see data mentioned at all up there in that main method, right? You do not see, you're calling the constructor, you're calling the public methods. You don't mention data. And that shouldn't be surprising, because when you use array lists, you don't know what the instance variables are in the first place to even name them. And same thing with strings, and same thing with scanners, and same things with maps, whatever. You don't know, you don't care, you just use the public methods, and that's what's going on here. We're just trying to make these methods work together the way they're supposed to. Now, no one has asked me yet a question I often get. And that question is, why did I use arrays inside to keep track of the elements of the list? What would be another option that would be easier to use? Think of all the Java classes you know. If you're going to implement a list, what would be easier thing to use as the instance variable than an array? Because arrays are fixed length. Array list. Right, so someone always asks me, why didn't you use an array list instead of an array? And the reason is, I was just trying to show you how you'd go about implementing an array list. Right? And it would be kind of circular to use an array list to do it. So if you look inside an array list in the debugger, like we just did with my lists, you'll see an array inside of it. Now, I have this other method I want to show you. It's called list timer. And let me show you how it works. We basically find out what time it is right now, down to the nanosecond. Then we're going to insert 200,000, we create an empty my list, and then we're going to insert 200,000 numbers into it. And then we're going to see what the time is. And then we're going to display how many seconds that took. And that should show up in the console down here. So let me just run this. This isn't, I don't mean this as a model of the right way to time code. This is a really crude measurement, but you get the idea. Now, you might think that adding 200,000 things to a list shouldn't take very long. But it took 14 seconds. I dare say that if we did this with an array list, in fact, let's just try it. Okay, I'm going to import that. Okay, so I just changed array list to my list. Let's time this. So array lists somehow do it in 1/10 of a second, or 100th of a second. It was taking me, what is it? 14. I figured it's like 1,000 times faster this way or something. I was trying to figure that out. So what magic is the array list using? I already told you it's using arrays internally. But let me put it another way. Why is the MyList implementation so slow? Yeah?
Because we're creating a new array every time.
Right. We're spending most of our time copying. Every time we go to insert, we make a copy. Now, when the array is empty when we do an insert, we're copying an empty array into an element array of size 1. That's not so bad. But that last insert, we're copying an array of length almost 200,000 to add an element to it. That's really slow. So let's suppose we're in the business of selling this MyList class. And we got all these happy customers, and they're using the class, and their code is working just fine. And then one day, one of them creates a really big one. And they file a bug report, and they say, you know, it took 14 seconds to add 200,000 elements. That's no good. So what do we do? How can we keep our customers happy? Yeah?
You can increase the size with each copy by more than one.
Okay, so he's proposing a particular strategy that we're actually going to use. But what things can we try? If the problem is we're copying the arrays too often, we just need to find some other way of representing the data in the array that doesn't require so much copying. Now, suppose we find a clever way. So what will we have to do? Say we think we find a better way to keep track of the contents of the array. In other words, we're going to have to replace the instance variables right here. They may have different names, different types, who knows? What are we going to also going to have to change about the class when we change the instance variable declaration? We have to change the constructor here? Yeah, probably. The instance variable may not even be called data anymore. So we'll have to change the internals of the constructor. We will have to change the internals of get and set and add and size. We have to change all that. And then we say, okay, here's the new version of my class. It's faster. Will the customer have to change anything about their code? After all, we completely changed the implementation of my list. But will the clients have to change anything about their code? No. Okay, and the answer is no. Why? Why, when we've changed so much, what is it that makes it so the customer doesn't have to change anything?
We didn't actually change how they call the methods, so we changed all the stuff that's private that we can
Exactly. Use the word private. Now, if we had called get something different or called set something different, then their code wouldn't work anymore. They'd have to change their code too. But all we did was change stuff that was private. That's why they're private. Instance variables are private so we can change them. That's a very powerful idea. If instance variables were public, if this were public, then who knows? Our clients may be depending, sometimes they may just go directly access the data field of an object. And suddenly when we change the internal representation, their code won't even compile anymore. We make it private in large part, so in the future we can change it. And no one that uses our class will be any the wiser. It won't affect them. That's the key idea. All right, let's take a break and then we'll see if we can speed this thing up. Okay, here's what we're going to do. We're going to design a new representation. I'm going to explain. I will draw the solution right here. So right now, if we have a list that contains 3 elements, internally it will contain an array that contains 3 elements, 8, 7, 2. And the problem is that to insert the 4th element, we've got to copy all this stuff into a new array and then add the 4th element. And as the arrays get longer and longer, the copying gets more and more expensive. And the result is it takes a long time to build a long array, a long list. So we're going to try a different approach, and here it is. Let's start, instead of creating an empty array to begin with, let's create an array of length 2. And so the first element to be inserted, let's say it's an 8, it'll go there. And the next element to be inserted will go here. And then, so in other words, we're leaving room to grow so that we don't force a copy every time. What should we do when we got to insert the 3rd element? Clearly, we got to make a bigger array.
Increase it by 2.
We can increase it by 2, but I'm going to do something even more radical. I'm going to double it. So what I'll do is when that array fills up and I've got to insert a 3rd element, I will double it in length, copying this stuff down. And then the 3rd element goes there, and the 1 goes there. And then what happens with the 5th element? We'll double it, and we'll copy down the 8, 7, 2, 10, and then 5 will go there, or whatever. So the effect will be there'll be room to grow, and at first there'll be very little room to grow before doubling is triggered. But as they get longer and longer, the doublings become rarer and rarer, right? So if at some point we have 1,024 and we double it, it'll take 1,024 more insertions before we got to double it again. So that's good that the doubling that happens frequently when the array is small are cheap, and the doublings that happen when the array is big are more expensive, but they happen less often. And it may not be immediately obvious that ought to lead to a faster overall implementation, but it does. Okay? So what instance variables do we need to make this work? If we cut one of these objects open, what will we find? Will certainly be an array. So we could have an array called data as one of our instance variables, but I think we need one more piece of information. Yes?
You can have one that keeps track of like how many pieces of information are in the array.
Okay. We need to keep track of how many elements are actually stored in the array and how much of the array is, or in other words, we need to keep track of how much of the array is room to grow. Okay? Because when we first create an empty list, the data array will look like that. At that point, what is the size of the list? If we were to ask what's the size of a newly created my list, what should the answer be? 0. Yet the array it contains is of length 2. So we can no longer use the length of the array as a stand-in for the size of the list. They're two separate things. So we're going to keep track of the second instance variable. I'm going to call it length. And that is the number of elements stored in the array that actually are really there. So like, let's say we've done another insertion. So at this point, the array has 8 elements. But what would the value of length be? How many of the elements of the array actually belong to the list? 6. 1, 2, 3, 4, 5, 6. So the data array might be that, and the length might be 6. And then you know that if someone says, what's the size of the list, you return 6. And if someone says, add element 10 or element 11 to the list, you know where to go. You know, you skip over the first 6 elements and put the number there, because that's the first place where there's room to grow. So we got to keep track of 2 things internally now. This array that has room to grow, and a count of how many elements are actually in the array that we care about. And we're going to do that without bothering our clients, because these are just private instance variables. And as long as we change the implementations of the methods of the constructor to be consistent, they won't tell any difference, except they'll notice it's way faster. All right, let's try that out. So back to here. So I've got another package with another MyList in it, so we'll start right there. And there they are. That's what I just talked about. I called them count here, but I called them length on the other slide. So to be consistent, I'll call this, what the heck? I'll call this length. Number of elements in the list. Actually, I say the number of elements in this list. What list am I talking about? The list on which the method was invoked. Remember, it's not like there's one length variable for the class and all objects share it. Every object has its own length variable and has its own data variable. All right, so we've talked about these comments sort of explain. These comments are really important because they explain how the representation works. And that's what I just did on that other page, so I won't read them again, but you get the idea. And this is important. The array has to be at least as long as the number of elements in the array, in the list. All right, what will it take to create an empty list? We've got two instance variables to initialize, data and length. So what should the value of data be? What should the value of length be? Second question is pretty easy. Remember, length is just the number of elements in the list, not in the array, the number of elements that are in the list that we're representing.
2 and 0.
Right, so when we start out, the length is just 0. There are no elements in the list yet. Nothing has been added to the list. Notice I keep taking pains to distinguish between the length, the number of elements in the list as opposed to the number of elements in the internal array. They're two different things. What array do we want to use? Before we did this, we said, give me an empty array. But I don't want to do that anymore. What did I decide we wanted to have? What kind of array did we have to start with? Yeah, I said one of length 2 for whatever reason. In fact, I'll be more conservative. I'll make it start out at 1, so the doubling will happen sooner. Because I want to show that to you in a second. Okay, very good. So we start out with a 1-element array, and we remember that, okay, there may be an element in the array, but we don't care about it currently because the length of the list is 0. The element in the array is just there for future growth. Let's add to the array. Now, let's suppose there's still room to grow. Where should the next element go? Let's go back to this picture here. So here we have this array, and at this point, the value of length, 1, 2, 3, 4, 5, 6, 7, would be 7. And clearly, this is where the next insertion goes, the first spot that's left in the array. There's only one in this case. What index is that? 7. So it turns out that we just store at index length. So let's go do that. We say data. Oh. So I'm typing all kinds of stuff here. Wow. This is giving me a bad... It's like no matter what I type. I'll try restarting Eclipse. I hope it doesn't take a long time like it sometimes does. All right, while it's restarting, let's think about what the code is going to look like. I can go back to this thing here. So we decided that we were going to put data sub length will contain the incoming value. What else do we need to do in the add method, assuming there's room to grow? Is it enough just to store the data in the array. Yep.
We want to iterate length, increase it by 1.
Yeah, we want to increment length. So we need to say length plus plus, or length equals length plus 1 or something. So we got to update both instance variables. We update data to keep track of a new element. We update length to keep track of the fact that there's one more element in the list. Okay. There's something about my computer that Eclipse time, it just seems to take a long time to deal with. I've always been afraid this would happen during class. There we go. Let's see if it'll work now. Wow. Anyone have any idea what's happening? Because I just typed D here and it. Yeah. Yeah, I don't know. Let's see. There's really nothing else that. Oh well. Sorry about this. I've had worse things happen in lecture though, so.